Hello and good day, Algebra. We are wrapping up our unit on parabolas with CO60, which is using quadratic equations in real context. We finally get to this is everything CO53 through PO59 has been practicing. We practice this, we practice that. Now we're to the game. Now we get to actually, run the play, so to speak, in CO60 here. So here's a brief review of things that you'll find helpful for CO60. So if you're unsure how to answer a question, these are different strategies you can use. It tells you what each thing represents, what it tells you. So if you need to know, okay, I have to find the highest point of this rocket. How do I find, oh yeah, the vertex is the highest point. I have to find the vertex. Here's the formula, here's how I find it, etc., etc. So number one, and we're going to practice this, actually sketching the graph can be helpful. Okay, sketching the shape of the parabola, if it's going to be really narrow, very wide, just a general idea of what it's going to look like and help you write in values and things like that. So we'll practice that one. But the y-intercept, how do you identify the y-intercept given an equation of a parabola? What is the y-intercept point? Yeah. The C value. 0C. Okay. And what does the y-intercept of a parabola represent? Yes, it's where it crosses the y-axis, okay? But it represents the y value when x equals 0. And so depending on what your x variable represents, if you're looking for, for example, if it's time, if you launch a rocket and you want to know, how high it is off the ground after 2 seconds, okay, then x would equal 2. If you want to figure out the launch point of the rocket, how high it is when you first launch it, then x equals 0, and the y-intercept would give you that. Okay, so it's the y value when x equals 0. What is the formula for the vertex of a parabola? Noah? Yeah. Okay, negative b divided by 2a gives you the x value, and then that gets plugged into the equation to find the y value. There's no special formula for the y value. You negative b over 2a to get x. That gets plugged into the equation to solve for y. We did that back in PO54. We did that in the discriminant review, CO58. Okay, and what does the vertex of a parabola represent? Yeah. Highest or lowest point. That minimum or maximum. Okay, highest or lowest point. Questions so far? We good? I'm going to erase his notes, so if you need them, write quickly. Anybody? Okay. How about that axis of symmetry? How do you identify a parabola's axis of symmetry? How did we draw it in, so to speak, in PO54? Alex? Okay, vertical line through the vertex. And what does the parabola's axis of symmetry do? We use it to find the reflection point because it serves a purpose. What purpose does that axis of symmetry serve? Julia? It's the middle, okay? It's the line of symmetry, and it's the middle. Okay. How that can help us. If we know that a soccer ball, for example, is kicked in a perfect parabolic shape, which of course they always are, right? And we know that, here's x equals 0, that's where the ball was kicked. If we know the axis of symmetry passes through at x equals 10, boom, the ball went 20 feet before it hit the ground, right? So knowing where that middle or that line of symmetry is, that's how we can use it to solve real context problems. Okay. X-intercepts. What are all the ways we've learned to find the x-intercepts of a parabola? There are 4 of them. 3 from PO55 and 1 from PO59. But what are they? Let me help you out here. If we have ax squared plus c equals 0, what's the method for that? Ax squared plus c, what could we use? I can't call on all of you at once, so some of you will have to put your hands down. I can't decide. Okay, I'll just... Opposite operations. That goes back to PO55. Opposite operations. We can do that because there's only one x term, right? That we move the constant over, divide by the coefficient, root both sides, and that's what give us our x-intercepts. Remember, in this form, your x-intercepts will be opposites. 2, negative 2. 4.1, negative 4.1, right? Always going to be opposites. Yeah, right. The quadratic formula, we'll use that one last, okay? That's from PO59. Another one from 55, ax squared plus bx equals 0. So there's no constant, but we have 2 x terms, so we can't use opposite operations here. What method do we use instead? Yes, in the back. A little louder. Yes, I don't know if you could hear that on the YouTube, but yes, pull out the greatest common factor, right? That was the taking out the greatest common factor. That's where we were first introduced to, what value for x makes this 0, things like that. The last method from 55, ax squared plus bx plus c. It's got all 3 terms in there. What method did we use for that? Swicky! Factoring, yes. Okay, factoring. And there will be times when the equation is just it's got some quirks to it, it's not factorable or whatever. And so what Brent said earlier, the method that will work every single time, no matter what the equation is the quadratic formula. I hope so. Yes, I did. Okay, the quadratic formula. That will work every single time. So if you remember nothing from PO55, which seems like that's the case, then the quadratic formula will work for all of them. Okay, but you just need to remember, in ax squared plus c, your b, there's no bx term, so b is 0. In ax squared plus bx, there's no c, so your c term would be 0. There's some things to keep in mind there, but it will always work. And what do the x-intercepts of a parabola represent? I mean, they're x-intercepts. What is an x-intercept? Noah? It's on the x-axis, okay? It's the x value when y equals 0. And so if you want to know, whatever your y value represents, if you want to know where on the x-axis our graph is when y is 0, then you can use them to find it. Back in our soccer example here, where the ball touches the ground, that's your x-axis, right? The x-intercepts of this parabola would be 0 and 20, where it's kicked and where it lands. And so if you're given the equation of the soccer ball and asked to find, how far did it travel, find the x-intercepts, and then goes 20 feet, right? So we're going to use some of that stuff today. Questions so far? All right. Let us begin then. Our first example, and it's like a 6-part thing here, but there's plenty of space to work. So Michael points a garden hose upwards such that the stream of water follows the path of y equals negative 16x squared plus 32x plus 5, where x is time in seconds. So we're given context here. Okay, the x variable, that x value represents time. How long has the hose been running? And y is the height of the water in feet. Okay, so x is time, y is height. It's important to know that because when you're asked these questions, if you don't know what variable you're solving for, that makes it doubly challenging. Letter A, sketch the parabola representing the stream of water. Okay, so it says it goes upward, and Michael's probably holding it, right? I mean, you don't want to hold on the ground and point it upward. That's not how you water things. So it's going to be probably kind of like this, right? Michael's holding it. The water goes up, parabolic shape, comes back down. Okay. If we kind of label this the y-axis here and the x-axis here, x being the ground, y being kind of where he's holding it, kind of his hand, okay? It's going to look essentially like that. Letter B, what was the initial height of the stream of water? By initial height, we're talking about where it starts. So I'm interested in what's the height of the water at that point. Now, how much time has passed when the water first starts coming out? 0. So we're looking for a time value or an x value of 0. What information involves there having an x value of 0, Brent? The y-intercept. Okay, and that's where sketching it can be helpful too, right? We can see that that's the y-axis there. Where the water starts coming out, that's the y-intercept. So what's the answer to this? What was the initial height? Look back at our equation. What's the y-intercept? 5, which in context is going to be 5 feet. Okay, so Michael is holding the hose 5 feet above the ground. On me, that'd be like right here, I think. Okay, there we go. How high will the stream be after 2 seconds? How high will the stream be after 2 seconds? What variable are we being given here? And how do you know that, Audrey? Because it's time, right? 2 seconds is a length of time back up here. X is time in seconds. So what we want to know is at x equals 2, which I'm going to estimate to be right about there, how high is the water? What do I need to do to answer that? What? Right. Plug 2 into the equation. Plug x equals 2 into the equation. So y equals negative 16 times 2 squared plus 32 times 2 plus 5. And what does that equal? Brent? 5? Do you have a second on that? 5? Okay. So what does that mean here? I mean, is it possible for the water to start at 5 and then 2 seconds later also be at 5? Yeah. How so? Gravity. Okay, so is my x equals 2 that I put there, is that in the right spot? No, right? Which is okay because this was just a sketch, right? Turns out that x equals 2 is going to be more over here. Because in order for it to be at 5 again, right? That means that it started at 0, it went up, it's coming back down now, and it's once again at 5 feet 2 seconds later. Okay? So adjusting our sketch, be open to that. I just put that 2 in there, not knowing how it's going to look, made the parabola. As you start to answer these questions, you have to make those logical decisions there. All right? Questions so far? Yeah, Quinn.
With this sketch, how could the water be higher than its original point?
Well, if the hose is going up, right, the pressure from the hose causes the water to go up. Yeah, garden hose. Yeah. So, okay. Other questions? And that's a good question to ask, right? Because since we're dealing with real context here, what we're doing should make sense. If you've got a question about it, it's good to ask it. Okay. What is the maximum height of the stream? I'm going to have to erase my work here to go down so anyone needs it. Anyone still jotting down notes? Okay. The maximum height of the stream, what are we finding here? While you think about that, let me redraw my sketch here. So we have 5 here, 2 is out here, kind of goes like this, something like that. I don't know. Okay, I heard someone say the vertex, right? And our clue here is the maximum height. The maximum height. Now, if we're looking for the maximum height, the vertex kind of has 2 parts to it, right? There's an x value and a y value. Which one do we care about? If we're looking for the maximum height, which variable is going to tell us the height of the water at the vertex point? X or y? At least, because I asked. She said, why? Because I asked. It's a dad joke type thing. Okay. Ugh. So we need to find the vertex here, but we really care about that y value. So calculating the vertex, negative b over 2a. If I remember the equation correctly, that's going to give us negative 32 over 2 times 16, which is negative 32 over 32, which is negative 1. That's not right, is it? Negative 16. Yeah, whoever said, how do you remember that? Well, it turns out I didn't remember it correctly. So positive 1. Okay. And in context, like if I was doing this on a test and I got an answer of negative 1 for that, I would automatically know that something's wrong here. Why? Why wouldn't a negative x value of our vertex make any sense? Noah. Because why? Remember what x represents, Josh? Okay. What does our x value represent in this situation? Right. This would represent negative 1 second if I got a negative 1 answer here. Okay. And you can't go back and it doesn't fit the question. All right. So negative 1, I would know, ooh, that doesn't make any sense. But I'm only using this to get the height of the water at the vertex. So I'm going to take that 1. I'm going to plug it back into my equation. Negative 16 times 1 squared plus 32 times 1 plus 5 is what? 21. Okay, so 21 feet. I did not make my sketch to scale. And that is a very strong hose. I'll tell you that much too. Okay, but 21 feet. Letter E, how long will it take the stream to reach the maximum height? So again, that word maximum there, we're dealing with the vertex, but this time, if the question is how long will it take to get there, which value of the vertex do I care about? The x, because that's the length of time, which I already solved for. How long will it take? 1 second. Okay, which makes sense in our drawing here, because if it's 5 feet at x equals 0, and it's again 5 feet at x equals 2, our axis of symmetry would be at x equals 1, which is the highest point, the vertex. And then finally, how many seconds until the stream of water hits the ground? And no, a little bit longer than 2 seconds doesn't count here. What do we need to find? Noah. How many seconds? That's one clue. Which variable are we talking about here? X. And hits the ground. What's significant about the x value when it hits the ground, Evan?
Y equals 0, so it would be the x-intercept.
X-intercept. Right? If it's on the ground, when it hits the ground, y is 0. We want to know what this point is here. When it hits the ground, at that point, y is 0. We're talking about the x-intercept here. Okay? So, given our equation, negative 16x squared plus 32x plus 5 equals 0. I don't know. Do you want to factor that? I don't really want to either. So let's go to the quadratic formula. So we get negative b, negative 32, plus or minus the root of 32 squared minus 4 times negative 16 times 5, all divided by 2 times negative 16. Because after all, when solving a parabola, we use the quadratic formula. There's a song about that. That's right. Anyway, so solving the discriminant first, I get 1,344. So negative 32 plus or minus the root of 1344 divided by negative 32, which is 2 times negative 16 there. Which is why, like I said, if you come without a calculator to the test, you're going to be in trouble. The root of 1344, any chance that's a perfect square? Of course not. Why would it be? It equals positive 36.66. So we'll round to the nearest hundredth, and we get negative 32 plus or minus 36.66 divided by negative 32. And so our two answers here, the first one will be negative 32 plus 36.66 divided by negative 32. And our second one will be negative 32 minus 36.66 divided by negative 32. Negative 32 plus 36.66 divided by negative 32, our first one, gives us negative 0.15 after rounding. Our second one, negative 32 plus 36.66 divided by negative 32 is, hold on. I do the same thing I just did. Negative 32 minus 36.66 divided by negative 32 is 2.15 when rounding. Well, the water can't hit the ground in two different spots. The question is, how many seconds until the stream of water hits the ground? Which answer is right, and which answer can we discard? Take a look at those. Negative 0.15 seconds, 2.15 seconds. I mean, technically, both of these, they are the x-intercepts of the parabola, right? If the 2.15 is here, the negative 0.15, if we kind of extended this back down, is going to be right about here. Okay? We don't care about this part because in context, he's holding the hose. If this hose was inserted in the ground, then we'd have the whole parabola there, right? So these answers are both correct for the parabola, but in context, which one's the answer? Bridget? It would be 2.15. First of all, this one's negative. The water can't hit the ground before it leaves the hose. That wouldn't make any sense. And also that 2.15 kind of matches up perfectly here with what we have sketched. Okay? So the other thing you have to remember here with dealing with these things in context is that the answer has to make sense. It's not just plug it in, calculate it, and this is my answer. It's x equals this. Does my answer make sense? Well, of course it does. Questions on this? Isn't this fun?
No. Too much work.
I need Soybe back. Okay. All right. Anyone else need these notes? Good. Okay. The next page is another. I think this. A soccer player. Here, kind of the example we used in the first page. Another one like this, we will go over this tomorrow, partly because I've got different homework for you tonight, and partly because those who are gone, I want them to see the full process here. So we'll go over this tomorrow. Then I've got some kind of graph interpretation stuff, where the graph is given to you and you just answer questions about what the graph tells you. Both of these pages will be due on Wednesday. So if you've got a busy night tomorrow night and you want to get some done tonight, then you can. If you understand it, you want to just go with it, be my guest. Otherwise, we'll do the rest of this in class as much as we can tomorrow, being a math day, and then the rest will be homework. Your homework for tonight, though, the most important test of the year is tomorrow morning, that math test for MAP, right? The average time it takes is about 65 minutes for 8th grade. So I want you to go to bed 65 minutes earlier tonight than you normally do. Now, for some of you, that's still going to be like one in the morning, so it's not, still going to stay up late. But get that extra 65 minutes of sleep tonight, so that for those 65 minutes you're sitting in that test tomorrow, you've got big brain focus going on. 66 minutes, and that last minute's going to be a real struggle, but you can persevere. Okay? For the test, like I said, I'm not beneath bribing you. It's already your middle square on your bingo board. Jeff is ready to supply you with all the sugar you can handle. And also, for every point that you exceed your spring writ goal, there will be a deposit, charity donation to your account in the Bank of Schultz. I will give you a piece of paper tomorrow that has your fall score on it and your spring goals, so you kind of know what you're shooting for. But as long as you do your best, folks, I mean, just remember it's a multiple choice test. You can usually eliminate one or two answers, and then from there, just pick the one that makes the most sense. There's no prize for finishing first. There's no shame in finishing last. It's your last NWEA test that you'll need to take. Let's make me look good is basically what I'm trying to sound. Sounds good. All right. Any other questions on this stuff? Okay.
What if y'all do bad?
If you all do poorly, then, oh boy, I don't know.
We should try that.
Let's not do that. Okay. That's high math.